guys, in today's tutorial I'm going to try to teach you a little bit about the function patch. The function patch is a patch that usually it's not used very often, right? Let's search for it here. This patch here. Let's read the description. It says, the function patch is an identity function. It always returns the same value as its argument. This patch can be used for scalar or vector values. And the patch output, it can be a scalar or a vector. So let's add this patch here. So here you can choose the type, if it's scalar, vector 2, vector 3, or vector 4. I'm gonna make two examples here of usage of this patch, and we're gonna use it as vector 2 because we're gonna use it in composition with texture, a 2D texture to create an image. So as we read in the description, it is an identity function. And what does it mean? It means that like the x and the y has the same value, like in this situation where we use vector 2. So for example, I'm gonna swizzle this vector 2 here, and I'm gonna put the result in one rectangle. So let's pick a rectangle here, fill width, fill height, okay, create a material, and this material let's choose for the shader type flat, and let's extract this texture here. Okay, so let's connect. So let's try first to understand what is happening here. Yeah, because we put only one value here, the x value, it is representing the alpha. So when the x coordinate is 0, you see my image here because it's transparent, right? It's the alpha equals 0. And when x equals 1, the alpha is equals 1 here. So you see only the rectangle, because the rectangle is white. If you choose the color, if you change the color, the color of the rectangle, you can see only this part here, because the transparency is not at 0 like this side here. Same thing with y. Up here, y is equal 0, right? The coordinate y, the y coordinate is equal 0, and here is equals 1. So there's no transparency here. Now let's represent all colors. So you can use x, y, 0, and 1 to be the alpha. So when you do this, so first let's go back to white here, so it doesn't interfere in our result. So now x and y represent the colors here, the R and G, right? Red and green. So when x is equal 0 and y is equal 0 and z is equal 0, because we put the 0 here, so everything is black. And at this corner where x is equal 0, no, x is equals 1 and y is equal 0, we have only the red component of the RGB, so it's red. Same thing here, x is 0, but y, that is representing the green component, it's gonna be green. And here is yellow because both y and x are equals 1. So for example, if switch here for 1 and 1, everything's gonna be yellow. So I'm doing this only to introduce you to this patch, so you can get a little understanding of what is going on here with this patch. So both x and y is gonna have always the same value. But now let's do something useful with this patch. We can use this patch here to to pixelate an image. And how can we do this? Let's add one multiply patch. Multiply. Let's set to vector 2. Let's connect here. I'm going to delete this whistle here. And now we need our camera texture, or any other texture that you have that you want to use. But in this case, let's use the camera texture. Let's extract. Let's put it here. And now what we're going to do is use the composition patch, this one. In the description, it says that it combines two functions. So let's combine these two functions here. This function is going to be our texture. And the other function is going to be the result of this multiplication here and the round patch. Let's use the round. And after this round, let's add one divide patch. And you need to set the same numbers in both multiply and divide patch here. So I'm going to start with 1 so you can see what happens. Let's add here, connect here. So that's my image with only one pixel, both in y direction and x direction and y direction. And that's because we put only one here in both directions. So let's increase this number to 4 in the x direction and 8 in the y direction. So it's not right yet because we need to put the same numbers in this divide patch here, 4 and 8. See? Now you can see a little better. If we count the number of pixels in the x direction, like 1, 2, 3, and half in this side and half in the other side here. So it's 4 pixels. Yeah, I don't know why. I don't know the reason why it is like that. It's not an entire pixel here. It's just half. And also in the vertical direction, the same thing happens. If you count, we need to have 8 pixels, right? Because we put 8 here. So it's 1, 2, 3, 4, 5, 6, 7, and 8 with half in this, because half is in this side and the other half is here. So you can keep increasing this number for a better resolution. Both in the multiply and divide. And this way you can get a pixelated image without using the pixelate patch. And you can keep increasing this number until the resolution of our screen. As we increase this number, the resolution gets better. Now you can see me more clear, right? And if you get the device here and we insert the screen size, we're gonna have my exact image, because now each pixel is gonna have the right size. Let's see what's gonna happen if I increase this number more than our screen size. Actually, I don't know what happens. Yeah, nothing changed. So what we also can do is stretch our image using only the divide patch. So for example, let's connect the function patch to the divide. Let's take this device from here. I'm gonna set to 1 again. So I have here my regular image, and if I put 2 in the x coordinate, you stretch in the x direction 2 times. If I put 3, I'm gonna stretch 3 times, and so on. In the y direction, same thing. You see it keeps stretching, and this corner here keeps on the same position. See, it's like a zoom. Just keep giving the zoom until, I don't know if there's a limit, but you got that, right? So what you can do now is put an add patch here, add set to vector 2, and now we can move our image around. For example, I'm going to move 0.5 in the x direction and 0.5 in the y direction. And now you have me here in the middle. Did you get that? Here you increase the zoom, and with the add patch you can move around our zoomed in image. Let's try to decrease this. See? So that's another thing you can do with this function patch. You can give a zoom to our image and move around with this add. Let's see if you add 1. So it moves too much. See? That's my shirt, part of my shirt. Go back here. Go back here. So I'm going to delete this patch again. So what happens is that the divide stretches the image a lot, and the multiply gets each part of the image and turns into a pixel. And the round patch rounds the color. So the pixel has only one color. That's how it achieves the pixelated image here. That's why we have to put the same value in the divide and the multiply patch. If we stretch too much, for example in the y direction, the image goes down, right? And same thing, if I stretch in the x direction, the image keeps stretching in the right direction, so you can't see me here anymore. What if I put one add here? Now, let's see. I am experimenting too. Oops. So now you have the pixelated image with a zoom. Let's keep increasing to see what happens. See, you give a zoom and you pixelate the image at the same time. Let's go back to our normal configuration here. That's what I had to teach you today. I hope you enjoyed this little trick. I also don't use this patch very often, so if you know another usage for it, you can comment below here. But I only know this usage, and I also know how to make copies of the image using the function patch. But I'm going to teach you this in another tutorial. So guys, I hope you enjoyed. Please give a like, subscribe to my channel because I have this English playlist so everyone around the world can understand. Even though my channel is mainly in Portuguese, but I have this playlist only in English so everyone can understand what I'm saying. I hope you're understanding. So that's it. See you in the next time. Bye.